Hello everyone, my name is Ali-Ayman and I'm an electrical and electronics engineering student at the University of Edinburgh. Uh, Believe it or not, this is the very first YouTube video I've ever made, and in this brand new YouTube channel, uh, I hope to specialize in study and also self-development and also other things that may help. So with the study, I'll be posting videos, hopefully on maths, physics, chemistry, and economics. This will be a mix. There'll be most of the videos, or a lot of them, will be about the content in each of these respective subjects. Um, and I'll also be making videos on exam practice for different exam boards, for different exam questions, study tips, etc. This will initially be geared more towards, the A level, IB, sort of group, and then hopefully, once I've posted enough videos on videos, for that particular group, then I'll, upload videos for more university related content, in this case for me, more related to electronics. For the self-development side of the YouTube channel, I'll be posting some videos for self-improvement, for motivation, for tips, for a number of different for study, not just for study, but for a number of different things. Whatever you guys want. And other videos I am heavily thinking of making are pertaining to finance, to the world economy, to politics. So much I want to there's a lot of different topics I want to touch on in this brand new YouTube channel. Hopefully it's a success and you guys enjoy the content. Today we're learning about, or I'm going to be teaching you about index laws. Relatively simple topic. So you can use the laws of indices to simplify powers of the same base. And the bases must be the same. In this case, especially in these first two examples, uh, the base is x. So the bases x in this case must be the same for both numbers. So the numbers we're talking about here are basically an integer or a real number x raised to a power, or to and this power n and m we call the exponent. N and m are the exponents. And obviously x, y, n, and m can be any real numbers. Um, so the rules we adopt when dealing with different examples here. They determine how we simplify these respective expressions, and we simplify them by manipulating their exponents. So in this first example, x raised to the power of n multiplied by x raised to the power of m, we this is basically equal to x raised to the power n plus m. This is always the case. For the second example, this one, x to the power of n divided by x to the power of m, it's equal to this, x raised to the power of n minus m. And then for the third case, we basically multiply the two powers. So here we've got x raised to the power n, and this is in brackets, and all of it is raised to the power of m. And the way we simplify this is by multiplying these two powers, and we end up with x raised to the power n times m. And for the last case, we've got xy. There's these, by the way, are multiplied together, so this is basically the same as x times y, and this simplifies to x raised to the power of n multiplied by y raised to the power of n. Okay, now let's look at some examples. So let's start off with part A. So with part A, this is the expression we have. Now, this is a typical example of expanding the brackets. So we must multiply minus 3x by 7x, minus 3x by minus 4. So let's start with the easier one. So minus 3x times minus 4. Minus 3x times minus 4. Negative times a negative gives a positive, so this will give us 12x. Now, with the other example, well, sorry about that. With the other number we have here, minus 3x times 7x. This is a case of using the laws of indices. So for minus 3x and 7x, we've basically got an invisible one here. We've got an invisible one. Another thing I should have mentioned earlier is that when we've got integers in front of this variable, when we've got integers in front of the variables x, we have to multiply these integers. So minus 3 times 7 is minus 21. And now we have to deal with the x's. So with the x's, we use the laws of indices. So x to the power of 1 multiplied by x to the power of 1 gives x raised to the power 1 plus 1, and this gives us minus 21 x squared. So the final answer to this for part A would be minus 21x squared plus 12x. Now for part B. For part B, this is what we've got. We've got y squared multiplied by 3 minus 2y cubed. And again, this is another example of expanding the brackets. So as before, we have to multiply y squared by 3, and we have to multiply y squared by minus 2y cubed. So 3 multiplied by y squared is straightforward. It's 3y squared. And y squared multiplied by minus 2y cubed is another instance where we have to use the laws of indices. So there's a 1 there. 1 times minus 2 is minus 2. And then we have to multiply these two variables raised to different exponents, but the bases are, as we said before, still the same. The base is y, and in this case we're multiplying, so we have to add the exponents. So it'll be 2 plus 3. The answer to this would be minus 2y raised to the power 5. Okay, so final answer for this would be 3y squared minus 2y raised to the power 5. Okay, now for part C. And we start off as before. This is another instance of expanding the brackets. So we multiply 4x by 3x, we multiply 4x by minus 2x squared, and we multiply 4x by 5x cubed. So the first one, 4x, and by the way, all of these will involve using the laws of indices. So 4x times 3x will equal 12x raised to a power. There's obviously invisible ones which we usually just leave out. So we've got 12x raised to the power 1 plus 1, which is equal to 12x squared. And then for the second one, we've got 4x raised to the power of 1 multiplied by minus 2x squared. And 4 times minus 2 is minus 8. So 4 times minus 2 is minus 8. And then 1 plus, sorry, it lagged there a bit. So, and then 1 plus 2 is equal to minus 8 x cubed. Okay, cool. And then for the last one, for part D, so for part D, we've got this time two separate expressions that we must expand. So we've got one here, so we've got, sorry, we've got one here and we've got one there. So for the first one, for this one, as before, we this is the way we expand it. We multiply 2x by 5x, and we multiply 2x by 3. And for the second instance, we multiply 5 by 2x, and we multiply 5 by 3. So let's start with the one on the left first. This involves the use of index laws. So like with these first 4 examples or so, these examples mainly use the addition index law. So 2x multiplied by 5x is equal to so 2 times 5 is 10, and then there's obviously a 1 there and a 1. There's obviously a 1 there and a 1 there. And when we add them, 1 plus 1, we get 10x squared. And then we multiply 2x by 3, and the answer to that is 6x. And then for the second expression, we've got minus 5 multiplied by 2x, which is minus 10x, and then minus 5 multiplied by, so minus 5 multiplied by 3, that's minus 15. So this will be equal to 10x squared plus 6x minus 10x, running out of room, minus 15. Okay, and then this this simplifies. We can now subtract 6x from 10x, and then this gives us 10x squared minus 4x minus 15. Okay. So I hope this this first couple of examples pertaining to the addition index law was clear enough. Now let's look at another set of examples. This time with the division index law. Okay, so part A. So we've got x raised to the power of 7 plus x raised to the power of 4, all divided by x cubed. This basically, so what does this mean? We basically, so when we write this down, we're dividing all the terms. So we're dividing all the terms in the numerator by x cubed. So we can write this down as x raised to the power of 7 divided by x raised to the power of 3, and then plus x raised to the power of 4 multiplied by, divided by x raised to the power of 3. This fraction obviously means division, so we can deal with this. So we can deal with this first, and then we can deal with this next. So x raised to the power of 7 divided by x raised to the power of 3 is equal to x raised to the power of 7 minus 3, which is equal to x raised to the power of 4. And then for the second one, we've got x raised to the power of 4 divided by x cubed, and that's equal to x raised to the power of 4 minus 3. The answer to that is x to the power of 1, or just x. So the final answer for part A would be x raised to the power of 4 plus x. Okay, now for part B. So for part B, we've got 3x squared minus 6 minus, so 3x squared minus 6x raised to the power of 5, all divided by 2x. Okay, and we can split this up. We can split this up as we did before. So this so we can write this down as 3x squared divided by 2x minus 6x raised to the power of 5, all divided by 2x. And we can deal with this on. We can deal with this first, then we can deal with this next. And eventually, you know, just like with anything, the more practice you do, this will become effortless, hopefully. So 3x squared. This thing is the same as 3x squared divided by 2x, and 3 divided by 2 is 3 over 2 or 1.5, whichever you prefer. Multiplied by x raised to the power, and there's a 1 there, multiplied by x raised to the power 2 minus 1, and that simplifies to 3 over 2 x raised to the power 1, or just 3 over 2x. And then for the second one, six x raised to the power 5. Oh, let me just get to it straight away. So 6x raised to the power 5 divided by 2x, there's a 1 there. This is, so minus 6 divided by 2 is equal to minus 3, and then x raised to the power 5 minus 1. This is equal to minus 3x raised to the power 4. Okay. So this expression simplifies fully to 3 over 2x minus 3x raised to the power 4. So that was part B. Now let's do part C. So we've got 20x raised to the power 7 plus 15x cubed all divided by 5x squared. And again, we can break this up. We can write it as 20x raised to the power 7 over 5x squared, because everything in the numerator is divided by 5x squared. That's why we can break this up. So this is equal to 20x raised to the power 7 all divided by 5x squared plus 15x cubed all divided by 5x squared, and we can deal with this on a case-by-case basis. So we end up with 20x raised to the power of 7 divided by 5x squared, and then obviously 20 divided by 5 is 4, and then so it's 4x raised to the power of 7 minus 2, and that's equal to 4x raised to the power of 5. Okay, now we deal with this one. So we've got 15x raised to the power of 3 divided by 5x squared. 15 divided by 5 is 3. So we end up with 3x raised to the power 3 minus 2, which is equal to 3x raised to the power 1, and that's 3x. So this thing fully simplifies to 4x raised to the power 5 plus 3x. Okay, so we've now finished the examples pertaining to the division index law. Now for the final set of examples, so for part A, sorry about that. So for part A, this is basically now a mix of all the different index laws. That's what this example basically has. So we've got a nice and easy one: x squared multiplied by x raised to the power 5, which is equal to x raised to the power of 2 plus 5, which is equal to x raised to the power 7. Okay, now for part B. We've got 2r squared multiplied by 3r cubed. Again, nice and easy one. So 2 times 3 is 6. So we end up with 6r raised to the power 2 plus 3. And that's equal to 6r raised to the power 5. And for part C, now we've got another division, another example which involves index law of division. So this is basically the same as b raised to the power of 7 divided by b raised to the power of 4, and that's equal to b raised to the power of 3, because this is the same as b raised to the power of 7 minus 4. Okay, now for part D. Part D, we've got 6x raised to the power of 5 divided by 3x cubed. So 6 divided by 3 is 2. So 2x raised to the power, and then we're dividing, so we're going to use the subtraction. Going to use a subtraction of the exponent. So 2x raised to the power of 5 minus 3, which is equal to 2x squared. And then for part E, we're now going to use two of the index laws at the same time. So in this case, we're going to look at the first index law the third case, the third index law we talked about at the start, which is we multiply 3 by 2, because a to the power 3 is all being raised to the power of 2, so we end up with a raised to the power 3 multiplied by 2 multiplied by 2a squared. That simplifies to a to the power 6 multiplied by 2a squared, and that, so obviously 1 times 2 is 2, and then now we use multiplication index law, so we add the exponents, so we end up with 2a raised to the power 6 plus 2, and that's the same as 2a raised to the power 8. And now for the last one. In this case, we're going to raise everything here, so we're going to raise 3x squared all to the power 3. So we'll start off with the integer, so 3 cubed, so 3 raised to the power 3, multiplied by the other index law we talked about. We have to multiply these two numbers, and this is obviously all divided by x to the power 4, and we can simplify this further by making it, sorry about that. 3 cubed is 27, and then 2 times 3 is 6, so divide that by x raised to the power 4, there's a 1 there, and that, so 27 divided by 1 is 27, and then we have to subtract these exponents, we have to subtract them, end up with 27 multiplied by x raised to the power 6 minus 4, and that's equal to 27x squared. So to summarize, there are basically there are basically 4 index laws. So one for addition, one for subtraction. The addition one is when we multiply two numbers which have the same base raised to arbitrary exponents. We subtract when we divide two numbers with the same base raised to arbitrary exponents. When we've got a number raised to an exponent, and then that's all in brackets raised to another exponent, we multiply the two respective exponents. And then for the last one, if you've got an expression which multiplies, x times y, x times z, anything, we raise everything to that power. So that's the fourth index law. So this is the end of the video. Hope you found this useful. If you did, please like, subscribe, and catch you guys in the next video.